Kamai Tawau, or welcome to NASA Connect. I'm Jennifer Polate, and this is the National Museum of the American Indian.
And I'm Dr. Stan Odenwald at an archaeological site in Mexico. Hola! This is NASA Connect, the show that connects you to math, science, technology,
and NASA. On today's program, you will see how ancient cultures found a connection to the stars. You will also learn how many of these societies were very sophisticated when making celestial observations.
You'll also learn about the mathematics and geometry used by these ancient peoples to make their observations. What you will learn today will absolutely astound you.
Observing celestial phenomena is the one constant that unifies humankind throughout space and time. Ancient man knew celestial events followed cycles, circles, and these events could be recorded. Approximately 5,000 years ago, they devised a way to place stones in certain positions to align for lunar and solar events. Events like seasons were noted and found to recur regularly with certain positions of the sun and stars.
The Earth spins on its axis once every day and gives us the familiar experience of daytime and nighttime. For thousands of years, humans have used this cosmic cycle to regulate their workday, their meals, and their sleep. The Earth orbits the Sun once every year, and from this we get the familiar 365-day cycle. Earth's orbit around the Sun is an ellipse. Basically, that means an oval, with the Sun offset from the center of the ellipse. Does this mean that we have summer when the Earth is closest to the Sun and winter when the Earth is farthest from the Sun? The surprising fact is that the distance from the Earth to the Sun has absolutely nothing to do with the changing seasons. Our northern hemisphere is closest to the Sun in January and farthest from the Sun in July. So what is causing the change in temperature? Earth's axis is tilted by 23.5 degrees from a line perpendicular to Earth's orbit. What does this mean? To understand this tilt, we have to use a bit of basic geometry. If the Earth rotated on its axis perpendicular to, or at a right angle to the orbit, there would be no changes in temperature. The Earth rotates at an angle 23.5 degrees from this perpendicular line. It's a very small tilt, but enough to affect the sun's rays hitting the Earth. The start of the four seasons, summer, fall, winter, and spring, are noted by what astronomers call the summer solstice, the fall equinox, the winter solstice, and the spring equinox.
Bill Nye, the science guy. Bill Nye, the science guy. Bill Nye, the science guy.
The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the Sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the Sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the Sun, it's daytime. And when you're on the part of the Earth that's away from the Sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the Sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill.
When the part of the Earth that we're on is tilted away from the Sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Watch this. If I hold this card like this, more light hits it than if it's tilted like this. That's why different parts of the Earth receive different amounts of light at different times of year. Of course, the Earth isn't flat like a card. The Earth is round like a ball. Let's say the Sun is over here. Right now, a lot of light is hitting this half, whereas up here, the light's more spread out. So right now, it would be summer here and winter there. Half a year later, be winter here and summer there. Of course, when it's halfway in between, it's spring or fall. Ha ha!
It is the tilted axis of the Earth which causes our days to be longer or shorter, and which causes the sun's rays to strike us directly in summer and at a slant in winter, giving us the 4 seasons.
Science! There isn't a whole lot of variation in temperature in the tropics. It's warm sometimes and hot other times. It never really gets cold. The Arctic areas are mostly just cold all the time. Parts can even go months straight without any sunlight. In the temperate areas, though, you basically have 4 seasons. Actually, here at 42 degrees north latitude, we're further away from the sun in the summer. 3.3% further away. Wrap your mind around that. So why is it so much colder in the winter? Because the Earth is tilted. It doesn't really matter how far away the tilt has moved us from the sun either. Again, at 42 degrees north latitude, I'm only tilted about 2,100 miles further away from the sun in the winter. That might seem like a lot, but the Earth is 93 million miles from the sun, so 2,100 miles is only about 2/1000%, which is much less than the 3.3% we get from orbiting the sun. And we already said that didn't matter. What the tilt of the Earth does is it changes the angle at which light hits the ground. There's a shallower angle in the winter, so the light is just sort of grazing the ground. In the summer, though, the angle is steeper, causing the light to hit the ground more directly. If the Earth were flat and facing the sun, there would be 1,365 watts per square meter hitting the surface of the Earth. Slap a simple atmosphere in there, and that goes down to about 1,000 watts per square meter, because the atmosphere absorbs some of the light on its way in. Fortunately, the Earth isn't flat. So how well do you handle your seasonal extremes? Let us know in the comments. And until next time, remember, it's okay to be a little crazy.